Hey, how's it going, everyone? This is FixerMed. Welcome back to my high yield biochemistry review series for the USMLE Step 1, NBME CBSE, and NBME CAS examinations. This will be part 15 of my multi part video series detailing and describing the entire discipline of biochemistry in a comprehensive but high yield manner. So, without further ado, let's go ahead and get started. Today, we're going to be mainly focusing on mechanisms of transport. So, there are passive and active transport. Those are the main mechanisms of transport that we'll be focusing on. Passive and active transport are mechanisms that facilitate the movement of substances across cell membranes. Passive transport relies on the natural movement of molecules from areas of higher concentration to lower concentration without the expenditure of cellular energy. This includes processes like simple diffusion, facilitated diffusion, and osmosis. In contrast, active transport requires cellular energy, typically ATP, to move substances against their concentration gradient from lower to higher concentration. Primary active transport uses ATP directly, while secondary active transport couples the movement of substances. The interplay between these mechanisms is crucial for maintaining cellular homeostasis. So, passive transport, which does not require energy, encompasses two main processes. Simple diffusion involves molecules flowing freely down their concentration gradient without the involvement of any transporter. An example is nitric oxide freely entering a cell. Then we have facilitated diffusion, which occurs when molecules move down their concentration gradient with the assistance of a transport protein. For instance, GLUT transporters aid in the facilitated diffusion of monosaccharides into the cell. Then we have active transport. Active transport requires energy input. It mainly comprises two major types. In primary active transport, ATP is directly utilized to move molecules. An example is the NAK plus ATPase pump, where sodium and potassium ions are actively transported using ATP. Secondary active transport involves the indirect use of ATP to transport molecules elsewhere. For instance, in the renal cortical collecting duct, the apical membrane's ENaC allows sodium to move down its concentration gradient from urine into the cell. This process is made possible by first establishing a favorable high to low gradient through a NAK plus ATPase pump, also sodium potassium ATPase pump, on the basolateral membrane as stimulated by aldosterone. So let's go ahead and move on to some NBME application-based reasoning questions. We have a researcher investigating a compound that effortlessly enters cells without requiring energy, and the compound does not accumulate within the cell. Which mechanism of transport best describes this process? Pretty straightforward first order question. Alright, I think I gave you guys enough time, so let's go ahead and move on and see what the correct answer is. Carrier-mediated diffusion aligns with the described mechanism where a compound is taken up by cells without the need for energy and does not accumulate within the cell. This process involves the assistance of a transport protein facilitating the movement of the compound across the membrane. Therefore, the correct answer here is D, carrier-mediated diffusion, facilitated diffusion / transport. Let's go ahead and see why the other answer choices are incorrect. Simple diffusion. Simple diffusion does not involve the use of transport proteins, and the described process implies facilitated diffusion. Active transport. Active transport requires energy, and the described mechanism involves energy-independent uptake. Osmosis. Osmosis specifically refers to the movement of water across a selectively permeable membrane and does not account for the compound uptake mentioned. Endocytosis. Endocytosis involves the engulfing of large particles or substances by the cell, which is not consistent with the described effortless and energy-independent process. Let's move on. A compound enters cells rapidly without requiring energy, and surprisingly, it accumulates within the cell. What is the most likely mechanism governing the transport of this compound? think I gave you guys enough time. Let's go ahead and move on. The described scenario of rapid energy independent uptake coupled with accumulation within the cell is consistent with facilitated diffusion. This process involves the assistance of transport proteins, channels, or carriers to facilitate the movement of the compound across the membrane, allowing it to accumulate within the cell. Therefore, the correct answer is D, facilitated diffusion, transport via channels or carriers. Let's go ahead and see why the other answer choices are incorrect. The incorrect answer choices can be explained as follows. Simple diffusion. Simple diffusion does not involve the use of transport proteins and typically does not result in accumulation within the cell. Active transport. Active transport requires energy, which contraindicates the energy independent uptake mentioned in this scenario. Osmosis. Osmosis specifically refers to the movement of water, and the described scenario does not involve the selective movement of water. Endocytosis. Endocytosis involves the engulfing of large particles, which is not consistent with the rapid and energy independent uptake mentioned in the scenario. So guys, that will be all for mechanisms of transport. If you have any questions, comments, or concerns, please feel free to leave them down in the comment section below. If not, this is FixerMed signing off. Good luck studying, guys, and goodbye.